Hi, my name is Ryan Strug, and this is the first video on my YouTube channel, Anarchist Bets. Basically, it is a pseudonym, brand name, story, narrative, whatever you want to call it, for as many crazy ideas as I possibly can think of. I do have a coherent goal, long-term message in mind, but it's not quite ready for the limelight. For now, I want to touch on topics that are important to other people and slowly work my way to what's important to me at a later time. Today, that issue is climate change. We have COP21, at least that's the Twitter hashtag, basically the climate change conference in Paris this week. And talking about climate change is kind of the big thing to do in the science community right now. So I want to go ahead and share a few ideas I have on it. I do want to take a somewhat moderate position. I am rather skeptical about the science that is out there. I frankly am skeptical about everything. But I do think that politicians should plan in case the greenhouse effect and anthropogenic climate change is real. I don't think there's anything wrong with that. I think preparing for the worst case scenario is the best and wise decision to do at this time. With that said, I don't think the greenhouse effect is real. I don't think CO2 is warming the planet. And I think all this is about nothing. But, like, the Pentagon has a plan in case Russia drops a bunch of nukes on the US. I think we should be in the same boat here, just in case. Because while I may disagree, and I may have some evidence in my favor, nothing is definitive in my eyes for or against at this time. So with that said, I'm going to go over the stuff that is important to me, and I hope that gets fixed. I hope the people who are paid to be climate scientists wake up and actually be climate scientists so I don't have to do this crap anymore. That would be awesome to me. But for now, I think it's important to share my ideas on this. Just a couple quick highlights. It's not as scary as you think it is. It is not the end of the world. It is not the sky falling, the apocalypse, all that. Now, three facts. I have three facts that I want to go over just to kind of put that in position. According to NOAA, which is a government agency, national. I don't actually recall what NOAA stands for right this second. I must be nervous. National Oceanic and Atmospheric Administration. Basically, they have a claim about hurricanes. I don't know if you ever heard about the claim that that climate change causes greater hurricanes. Like, I think there was a massive one that just hit Mexico, and they were like, oh, we got to do something about climate change, climate change, climate change. Well, I have a quote. I have the website and links. I have a bunch of links right below this video that you can view later on. I have a link to a page from NOAA that says, it is premature to conclude that human activities, in particular greenhouse gas emissions that cause global warming, have already had a detectable impact on Atlantic hurricane or global tropical cyclone activity. There's more about it, and they do theorize that it does have an effect on hurricanes, but they don't have any evidence of it. So to freak out about it is pointless. Hurricanes are not caused by climate change at this time that we are aware of. There is nothing for it. It's like imagining a meteor that's coming towards Earth that we can't see. Which there could be, I mean, you never know, but it's not something you would react to. So moving on. I'm sure you've heard a lot about the 2 degrees Celsius, Fahrenheit, or I think it's Celsius, or no, it's Fahrenheit. It's Fahrenheit. That they want to cap raising temperatures at just 2 degrees Fahrenheit. So it's even less. Wow. The temperature globally, according to NASA, and I have a link as well, this is climate.nasa.gov, the global temperature since 1880, which is pre-industrial or whatever it is, has only risen 1.4 degrees Fahrenheit. And they want to cap it at 2 degrees Fahrenheit. So the goal is to just cap it so it only rises 0.06 more. That's it. It's not, oh, it's going to go up 1 billion degrees, 3-4 degrees. We're only going to cap it at 0.06 is the goal here. It's not 2 degrees, it's literally 0.06. So it's not a huge thing that they're freaking out over. Something else, the ice in Antarctica is growing. I have this link as well. NASA study, mass gains of Antarctic ice sheet greater than losses. It's only the Arctic and only Greenland that they're claiming ice loss. Not Antarctica at all. That is actually wrong in the IPCC report, which is the Intergovernmental Panel on Climate Change that the UN set up to determine whether or not climate change is a thing and what we should do about it. They claim that the Antarctic ice was getting smaller and shrinking and melting and adding to the ocean. Well, it's not. So they were wrong. And that, to me, says a lot about the science to begin with. A lot of it is wrong. Some of it is right. To claim that none of it can be debatable is just, that is the real denial in my mind. All right, the next thing I want to talk on is a little bit of statistics. A lot of people like to use, there was a pause, 10-year pause, statistics. There's other things that I think stand out in my mind at least. From 1910 to 1940, the temperature rose while CO2 emissions remained virtually unchanged. Then from 1950 to 1980, the temperature remained unchanged and CO2 emissions rose. Both these variables moved without affecting the other. That happened in data sets that we have from NASA and the EPA in the last 150 years. Like, you don't even have to worry about 10 years. You can look at 30-year periods in the 20th century where these two did totally different things. CO2 did one thing, temperature did another. So anybody anywhere who tells you that CO2 correlates with temperature is a fraud. Seriously. You can take a look at the map, the graphs yourself, and go, hey, did it move? No. Did it stay still? Yes. I mean, so you can't use statistics here. And I wouldn't use statistics anyway to prove this regardless. Like, it's more of like, oh, it shows like a pattern of what it could be there, what could not be there, but correlation does not imply causation is a popular phrase I hear a lot in the science. It's not. So even if it correlates or it doesn't correlate, it doesn't imply anything. So it's just a fun little pattern thing. It might trigger an idea that you have that might lead to something later on. Okay? So I did that. Conservation of energy. I just wanted to quick highlight. This is already a long video. I meant to make this like 5 minutes. It's probably like 15. I apologize for that. The law of conservation of energy is the total energy of an isolated system remains constant, according to Wikipedia. It is said to be conserved over time. Energy can be neither created nor be destroyed, but it transforms from one form to another. For instance, chemical energy can be converted to kinetic energy in the explosion of a stick of dynamite. Essentially, that means that a perpetual motion machine of the first kind cannot exist. That is to say, no system without an external energy supply can deliver an unlimited amount of energy to its surroundings. What does that mean? It means when light travels, light can't produce an unlimited amount of energy. The energy is used or converted into other forms. Essentially used would probably be more colloquial or common. Used on stuff. And it's no longer traveling with that light at that point. As soon as it's used, it's gone. Or it converts to something else. Now, I want to talk about the greenhouse effect. And I will get back to the law of conservation of energy in a second. I have a quote from the IPCC FAQ page from the 2007 Physical spaces, or the fourth assessment report in 2007. I think there's one that's a little more recent, but essentially this is the same organization. Their same ideas on how this, and this is the fundamental stuff. This is the stuff they taught people in kindergarten or whatever, elementary school, and they claim to be so fundamental that can't be debated at all, and there's just no debate whatsoever on this. But I think this is the most critical part of the entire theory, is the greenhouse effect. Now, they say here, to balance the absorbed incoming energy, the Earth must, and I'm going to emphasize this, it says must, on average, radiate the same amount of energy back to space. So their idea is that all the sunlight from the Earth, from the sun that comes to the Earth must go back out at the exact same level in order to be balanced. At the exact same level. So all this light that travels, and it travels back, has to be the exact same. That's their entire premise for the greenhouse effect. That is their entire premise for all these scientific models that say CO2 and all these greenhouse gases are causing global warming. That is basically it. The problem with that is that energy is used on stuff. Energy is used or converted to other things. The easiest example I can think of, and I thought of several, is the solar panel. You have light from the sun that shines directly on the solar panel. The solar panel absorbs this energy and stores it in a battery or sends it to whatever. It takes the energy out of the little sunlight greenhouse effect pattern thing that they have here. They like to call this concept radiative forcing, which is basically the difference between the amount of energy absorbed by the Earth and the amount reflected. Let me actually get the real definition. I'm going to skip ahead. I apologize. I don't mean to be confusing. I'm getting to the rocket science part soon. So if it gets too much for you, don't worry about it. But I believe you're smart enough. So the official definition for radiative forcing, according to Wikipedia, which to me is somewhat official, is defined as the difference of insolation, which is sunlight, absorbed by the Earth and energy radiated back to space. Which is basically what I said, I think. So, okay. So, you have your solar panels taking the light out of that little system. It's not going to get back into balance. Those are the people that are in charge of this. And they didn't even think about solar panels. They're like, oh, everybody should be using solar panels, right? Well, guess what? It actually throws off their whole little claim to be killer. Some other things that I think are important. Photosynthesis, the light that comes onto plants. And I think it's a biological function. I think it's similar to respiration. I do not know how much about plant biology to categorize that process into something greater. But basically, it's the process that converts CO2 to oxygen, and it uses light to do that. That light's not going back out. That light got absorbed by the plant. Cold-blooded animals, they warm their bodies the same way. They use the sunlight. UV radiation to vitamin D. You go out in the sun, you get vitamin D. Humans get vitamin D that way. You also get sunburn. That light energy is not going back out to space. All right. Okay, so basically the greenhouse effect. You have all the sunlight coming from the sun. Some of it's reflected by the clouds. They consider that having gotten to Earth. Some of it hits the Earth and is reflected back out to space. Some of it actually is completely absorbed by the Earth. With the expectation then that the Earth sends out infrared radiation, which is then sent back out to space, which is where they get all the measurements and stuff. They're like, oh, it's converted from visible light to infrared light. And as soon as it comes back from the Earth, it goes up, hits the greenhouse gas, and is absorbed by that greenhouse gas, and then goes in all kinds of directions. It goes up, down, bottom, everything around. When it goes up, back out to space, that's the stuff that gets away. But the idea with the greenhouse effect is it's sent back down, it's absorbed, and then sent back down. Now, I think a lot of these climate scientists truly believe that it gets trapped, the heat gets trapped by the greenhouse gas, that it is caught on Earth and it's going to stay there forever. That's what warms us, because if the greenhouse gas was there, the warmth would go away, which is ridiculous, because thermal energy is converted to other forms of energy. So when you warm your pizza, you cooked it. The pizza gets cooked. The cheese melts. These chemical reactions take place, however it's best described. The sauce does whatever it does. The crust gets a little harder. Stuff happens. Motion happens. Motion is caused by this thermal solar energy. The hot air balloon, for instance. You light the fire under the air, the gas expands, it gets wider, it moves around, it gets faster, it bounces around more, creates buoyancy and allows you to float. When this happens to gases in other parts of the atmosphere, the energy that gets re-emitted, that was absorbed, is less than what came into it. It's less. Basically, that heat is going to go away. It's not going to go back out to space, necessarily. It could, still, if it's strong enough, I suppose. It's going to float around on the planet and eventually be used up or converted into other forms of energy. It's not a big deal. It happens. Essentially what this means is everything that's quantified for the greenhouse effect, radiative forcing, is irrelevant. We're relying on a hypothesis that has not been experimentally proven at all. Like, there's no numbers for the greenhouse effect. That's like saying, this is how the world works. Like, the Earth is flat. The Earth is flat. Why? Because I said so. I don't know how to measure that. I don't know anything about it. It's because I said so. That's the greenhouse effect today. That is the state of that science. For the record, if the Earth was flat, why does the sun go away at night? It must hide behind its wall or something. Oh, you mean you could fly with the sun as it goes around and you could see the sun? Like, but you can't see it on other parts of the flat Earth? It's ridiculous. Anyways. Excuse me. I think I have two more things. Yes. Okay, I already talked about most of radiative forcing. All right, you will see radiative forcing. You'll see numbers and measurements that go from 1750 all the way to today. That is the biggest load of crap you will ever see, ever. The first satellite we sent into space was Sputnik in 1957. That is the first opportunity, and it wasn't a weather satellite. It was just, I think it was just a satellite to go to space. I think the first weather satellite was a few years later. That is the soonest we could ever measure the amount of light energy coming from the sun before it got to Earth. That is the only way we could have done it. Because there's no way to see what's on the other side of the atmosphere without getting to the other side. So we had some weird giant telescope or something. Even then. So to see these numbers, it's just you made a model to the past? Your sample, it's just, it aggravates me so. It really does. So what you'll see on the radiative forcing components charts is you'll see these giant bars and these confidence lines that these bars fit under these confidence lines. So basically, they say radiative forcing for a particular greenhouse gas, or we'll use something else. One of the ozones is actually less. The entire size of the ozone, let's say it's 1.4, is less than the confidence level, which is like another 0.5 or something. So if you have your entire number fits inside the air margin, I think. I gotta look up statistical terms again. I apologize. I promise I looked this up before. I just don't recall right this second. If you can't fit your number inside your level of precision, there we go. Let's look at this. So you have like a survey, for instance. You have 40% people plus minus 3%. I'm sure you've seen that before. That's what that's like. So you have 1% of people agree on something, plus minus 3%. Does your statistic matter? Did you say anything? That's literally every single value there, just about. That is the IPCC. That is the report that freaks everybody out and causes people to want to spend billions of dollars, march on Washington, do all kinds of things. The very last thing I want to talk about is something that's literally labeled with rocket science. It's from the Jet Propulsion Laboratory at the California Institute of Technology, NASA's laboratory at CIT, from their website, nasa.gov. It talks about how they measure carbon dioxide on the planet. They look at the wavelengths that they measure from space, particular wavelengths of the light. They kind of determine what it is, whether or not it's some type of infrared or visible light or whatever. They can apparently see the wavelengths of the light and measure it and identify a particular gas using a satellite from space. I actually have more problems with this than I care to admit. It is rocket science, so I'm not embarrassed at all if I misunderstood this at all. It's rocket science. It's rocket science. How many times have you heard that quote? It's just rocket science. So, and it's labeled Jet Propulsion Laboratory, rocket science. So, basically, they have two wavelengths attached to CO2. They're like, if these wavelengths are measured by the satellites, CO2 is there. Because CO2 emits a particular wavelength of light that is absorbed by no other gas. Like it just travels through all the other gases. Because the other gases pretend that wavelength, that light does not exist. The infrared light does not exist. My problem with this, a little bit, is something called gravitational redshift. It's something in general relativity. That's Einstein and everything. That as light travels in a gravitational, in a field with a lot of gravity, it changes, it gets redder, it goes closer to infrared and farther away from ultraviolet. The wavelength gets, I want to say, longer. Could be wrong. It goes towards the red side. Okay. As it travels, this happens. As it travels in a gravitational field, this happens. Okay. From space, you have your satellite. And if I've lost you here, that's fine. I got 99% of everything I wanted to say out of the way. Though I do have one more thing on ice. We'll get to that at the end. 99% of, excuse me, let's start over. All the light that comes from the Earth and hits the satellite is what that light is when it gets to the satellite. You cannot see light that's 100 yards away from you until it gets to you. Light travels. Light has a speed of light. That is the current prevailing theory right now. If light travels, you cannot see 1 yard away from you. You cannot see what this light is 1 yard away from you. You see it when that light travels to your eyes. Light gets to you. As soon as you see it at your eyes, that's what that light is. You're not seeing what's on the ground. So they have the satellites, the OCO2 mission, and they're looking for the carbon dioxide that's on the ground. The carbon dioxide that is closest to Earth. You cannot see the light at that level from space. You're seeing the light after it travels through everything. I think the idea is that they're like, oh, it's not absorbed by anything else. It's just going to travel and make it all the way out. And maybe it doesn't matter. If all light is affected by gravitational redshift equally, maybe it doesn't matter. But it's affected. What it could affect is if you can measure this infrared, the light at the ground level, and compare it to the measurements up top, it's not going to be the same at all, unless you account for gravitational redshift. With that said, apparently, if CO2 absorbs light at a very specific wavelength that no other wavelength or no other gas absorbs, and visible light travels through CO2 to begin with, and which is basically what the greenhouse effect is. The visible light comes from the ground, or comes through the sky. CO2 doesn't do anything with it, and then it converts to infrared, comes back out, and then CO2 traps it, or absorbs it, sends it back, and traps and all that. Trying to interchange multiple terminology here to try to reach as many people as I can. If it does that at a specific wavelength, and according to the site, it has only 2 wavelengths, that means when it gets re-emitted and has a lower wavelength because it used energy. When it uses energy, it gets a lower wavelength. I think Compton scattering is what we know about that, where it explains it with gamma rays and X-rays. I wasn't able to find anything specific about lower levels of radiation and light, but I'm looking. I'm not finished with this. This is the rocket science part of the video. If it can travel as visible light through the CO2 and it gets re-emitted and it hits that lower level, it's no longer trapped. It travels through the CO2 again. The CO2, like, obviously that heat doesn't matter anymore. That light doesn't matter. Like, as soon as it's converted, it's used at that particular wavelength, it can just travel right back through. So you have, according to the site, 2 wavelengths where they're like, hey, CO2 has these 2 wavelengths. This is where the CO2 is. This is the level that is absorbed and emitted. It gets lower than that level for whatever reason. It flies through. It doesn't matter. It's only bounced once. It's not infinitely trapped by this level of greenhouse effect. It's one time at most. I guess 2 times, since they have 2 measurements here, but I don't trust this data at all. I would not bet billions of dollars on this at all. But it is rocket science. Perhaps I completely misunderstand it. I cannot rule that out, because unlike a lot of scientists, I admit I am a human. I am just one person. I don't know everything. I could be wrong. It is not unequivocal. With that said, I am very confident that we don't know enough about this to bet billions of dollars. The rate, it was like 1.4 degrees Fahrenheit since 1880. In another 50 years, 0.6 degrees Fahrenheit is nothing. They could cut all these emissions, hit that target easily, say it's because they cut the emissions, and it could have no effect whatsoever, and nobody would know. When you don't have the greenhouse effect experimentally quantified, it's just a hypothesis. It's not unequivocal. It's just a theory. Last thing I mentioned, I wish I had mentioned this earlier. I should have written this down. They have satellites that measure ice from space. That's how they get the the area. But when ice forms, it melts at the edges, turns into the sea. Sea evaporates, condensates in clouds. Clouds rain, drop rain on top of the ice sheets in Greenland, the Arctic, and in Antarctica. When it creates the ice in the middle of the ice sheet, when it does that, it's like taller in the middle than it is on the edges. How do they measure with their ice measuring satellites the ice at the bottom in the middle of those sheets? How do they know that they know it's getting bigger in some places, but how do they know from the satellite excuse me, from the satellite how tall the ice is? How do they do that? Do they account for that? In their ice loss measurements, do they account for all the growth in the middle enough? It just worries me. I really think they're being incredibly lazy, fudging numbers in a lot of different places. A lot of these climate scientists are. And people are going to spend billions and billions of dollars on this, on things that could be spent on other things that are more important. Like, if climate change is not a big deal, we could be building toilets in Africa, better infrastructure for supply chains, improve food, all kinds of things we could spend that money on. That's more important and more charitable. And we could be completely wasting it on something that doesn't matter. That upsets me a little bit. So, enough to make a 32-minute video. If you made it this far, thank you. This is my first attempt. I will try shorter videos in the future. Hopefully I said something smart. It's all on my Twitter feed, so if you don't like watching a video, it's all there. So, alright, cool. Happy COP21. Best of luck. Save the environment. Take care.